outcome by the end of this lesson. What is Deque? Properties of Deque, types of Deque, representation of Deque using secular Q, different operations in Deque, implementation of Deque, and last is application of Deque. Deque is a data structure that inherits the properties of both queues and stacks. Additionally, the implementation of these data structures requires constant time complexity. This means you can use the queue to your advantage to implement both the queue and stack. So, in this tutorial, you will discover the queue in a data structure to understand its functionalities and applications. What is the queue in a data structure? The queue is a more generalized version of a linear queue. As you know, the linear queue has some restrictions while performing the insertion and deletion of elements. The insertion in a linear queue must happen from rear and deletion from the end. But in the queue, you can perform both insertion and deletion operations at both of its ends. That's why it is called a double-ended queue. This image above represents how different operations take place at both ends of the queue.
Properties of Deque. Now, you will look into the primary properties of Deque in a data structure. A Deque can perform both the insertion and deletion using the LIFO last in, first out principle. The insertion and deletion in Deque can be limited to one node. When you do that, the Deque becomes a stack. Hence, it follows the last in, first out principle for insertion and deletion, as shown in the image above. Initially, there were 4 elements inside this Deque. However, after repeating the removal of an element twice, data elements 2 and 12 get removed from the Deque, respectively. You inserted element 2 at last and removed it at first. This example demonstrates the LIFO principle. A Deque can perform insertion and deletion operations using the FIFO first in, first out principle. As Deque can operate on both ends, you can extract queue properties by limiting insertion at the front node and removal at the rear node. Doing this will allow Deque to act as a linear queue. As shown in the image above, the element which enters at first will also leave the queue first. This is how Deque can use the FIFO principle to perform insertion and deletion.
Types of Deque in data structure. Deque or double-ended queue is a type of queue in which insertion and removal of elements can either be performed from the front or the rear. Thus, it does not follow FIFO rule or the first in, first out rule. There are 2 types of Deque which are created by restricting certain operations. Let's clearly understand them. First is input restricted Deque. It is a Deque with some limitations while performing insertion operations. In the input restricted Deque, it will perform the deletion at both ends, whereas it performs the insertion at only one end. The image below shows how input restricted Deque limits insertion at one end. In short, an input restricted Deque is one where deletion can be made from both ends, but insertion can be made at one end only. Next is output restricted Deque. It is a Deque with some limitations while performing deletion operations. In the output restricted Deque, it will perform the insertion at both ends, whereas it performs the deletion of elements at only one end. The image below shows how input restricted Deque limits removal at one end. In short, of the output restricted Deque, one of the least restricted cases of Deque is that in both which insertion and deletion are permitted at one end, but at the other end, only insertion are allowed. Hence, it is called output restricted.
Operations on Deque. For basic operations are performed on Deque. They are as follows: insertion at rear, insertion at front, deletion at front, deletion at rear.
Operations in Deque. To implement Deque using a circular queue, you should be able to implement the insertion and deletion at both ends of queue. Let's begin with implementing insertion of both ends. Insertion at rear. First, understand insertion using the rear node with the help of an example. Initially, there is only one element inside the queue, hence both front and rear are pointing to the index 0. Additionally, as you are inserting elements using a rear node, its incrementation will bring you to the empty space for putting in a new element. The image shown above represents how insertion occurs using a rear pointer. 2. Insertion at front. Let's deal with the insertion using a front pointer. Consider the example given below. In this example, a front node points to index 0, and now you want to insert elements using it. In order to do that, set the front pointer to max size 1. Doing this will allow your front pointer to reach the end of a queue. After that, you can insert a new element at this new location. But for the further insertions, you will just decrement the value of a front pointer. The diagrammatic representation above explains insertion at front operation. Deletion at front. Consider the diagrammatic representation of a circular array given below. In this representation, a front node is pointing to index 4 and a rear node to index 2. Now, to perform the deletion, you will have to increase the location of the front pointer until it reaches the max size of queue. For further deletions, set a front pointer to index 0. The diagram below will help you to visualize that. 4. Deletion at rear. The diagrammatic representation given below explains how you can perform deletion operations using a front node. In this example, the rear node is at index 2. To perform the removal of elements, reduce the location of a rear pointer until it arrives at index 0. Once it reaches the index 0, you will either set it to max size 1 if there is an element inside the queue, or negative along with front equals negative 1 if there is no element inside the queue. Once you are clear with the different cases for both insertion and deletion, you will dive into the implementation of in a data structure.
Representation of Deque using circular queue. The Deque can be implemented using either a circular queue or a double linked list. The circular queue implementation of the Deque is the most straightforward approach to implement a double-ended queue. Hence, in this tutorial, you will only focus on the circular queue representation of Deque. Primarily understand what a circular queue is. What is a circular queue? A circular queue is an extended version of a linear queue, as it follows the first in first out principle, with the exception that it connects the last node of a queue to its first by forming a circular link. Hence, it is also called a ring buffer. The illustration of a circular queue below shows the connectivity between the queue first and last mode. Additionally, a circular queue manages memory efficiently because of its circular link. If the rear pointer has reached the max size of a queue, it will again arrive at the beginning of a queue is called circular incrementation. The image given below shows how to achieve circular incrementation. You must be clear about the concept of a circular queue. Now, moving ahead, you will look into how to implement the Deque using a circular queue.
Implementation of Deque. As mentioned previously, you will implement for main primary Deque operation as listed below. Front inquiry. In Z, insert element using front node in a Deque. Rear inquiry. In Z, insert element using rear node in a Deque. Front Deque removes element using front node in a Deque. Rear Deque removes element using rear node in a Deque. You will use the C programming language to implement Deque in the data structure using a circular array.
display function implemented in this program is an additional function that we have to implement to visualize the state of a Deque. The image given below is the output that you will receive after running this code in a compiler. Applications of Deque and data structure. The Deque can act as both the queue and stack. Thus, all the applications of queue and stack can be implemented using a double-ended queue. Given below are some critical applications of queue in data structure: palindrome checker and multiprocessor scheduling.
Palindrome checker. The string or a number that reads the same backward as forward is known as a palindrome. The program to check if the given string is palindrome or not can be implemented using Deque in the data structure. If the string reads the same from both the Deque ends, it will consider it palindrome. The image given below a structure or a palindrome checker implementation using a double-ended queue. Multiprocessor scheduling where multiple processes are being executed by multiple processor CPU core in a system. Then the system utilizes multiprocessor scheduling algorithm. In this algorithm, the Deque is used by each processor to store different threads of processes. That algorithm is also called that A-still algorithm for scheduling. That illustration given below represent the process of multiprocessor scheduling.